Right. In this fourth installment of Applications and Systems Equations, we're going to be moving into three variable systems. So this would be a good time if you have not going to see old videos or any practice with three variable systems, please go ahead and do that now and then come back to this video. So just like with any other application problem, the first thing we're going to want to do is define our variables and to see what equations we can set up. So I'm going to read through the problem to give us an idea of what's going on and then think about what formulas we could set up here. So it says when Caitlin went to the store with $10, she saw that she had some choices about what to buy. She could get one apple, one onion, and one basket of blueberries for $9, or she could get two apples and two onions for $10, or she could get two onions and one basket of blueberries for $10. Write and solve a system of equations with variables. So here it actually gave us what to label them. We're going to label A as apples, onions as N, and B as blueberries. Now you might be wondering why I'm doing N for onions, but that's because O looks too much like a zero. So we're going to do N instead. And so we need to be able to set up these three different equations. So I'm going to go back to the first sentence. It says she could buy one apple. So an apple, one onion, plus an onion, plus one basket of blueberries. So one blueberry is going to be $9. Then she could get two apples. So 2A plus two onions, 2N, was $10. And the last example was two onions. So 2N plus one blueberry, and that was also $10. So reading through the system, or reading through the examples, and really just setting up these equations based off of the information given to us. Now that we're here, we're going to go ahead and actually try to solve the system. So the first goal in solving a system with three variables is to just get rid of one of your variables altogether. Use elimination, get rid of one of your variables, and then you have a two variable system left to solve. There are many different ways that we could do this, but I am just going to choose. I see that every equation has an n, so I'm just going to get rid of that n. I'm going to eliminate n. So my goal one is going to be eliminate n. I'm going to start with the one that looks like eliminating n the easiest, which is these two. And so my first one is going to be 2a plus 2n equals 10. I'm going to multiply the second one by -1. So that's going to give me -2n minus b equals -10. When I combine those, I do see that the two n's cancel. My a and my b I cannot bring together, or I can't cancel or combine because they're not like terms. So that's going to leave me 2a minus b. Weirdly, my 10s also cancel, leaving me with 0. I do want to bring that 0 down because I do need something on that side of the equation. All right, so now that I've used two equations to eliminate n, I have to bring in the third equation somehow. So I have to use this one. I could choose either the middle one or the bottom one. It does not matter here. I personally am going to choose the middle one, but once again, it would not matter if you chose the other one. So I'm going to have a plus n plus b equals 9, 2a plus 2n equals 10. In order to get rid of the n's, I need to multiply this first one by -2. So that is going to give me -2a minus 2n minus 2b equals -18. And then I have 2a and 2n equals 10. I'm going to go ahead and combine those. Interestingly, my a's cancel as well. So do my n's, leaving me with -2b equals -8. Oops. Now, in theory, my only goal was to eliminate n. I would then go back and use the two equations that I solved. I'm going to highlight them in blue. I now have a two variable system that I could solve. But we got lucky. This over here doesn't need to go any further, or it needs to go slightly further, but there's no a in it. So all we have to do is actually solve for b. So if I divide both sides by -2, we get that b is equal to 4. I can just go ahead and plug that in here. So goal 2 is going to be just solving the system that we have left. Well, we have b equals 4. Plug that in. 2a minus 4 is equal to 0. So 2a is equal to 4. So a is equal to 2. Which means we're actually super close to being done. Goal 3 is actually going back and solving for your last variable, which is n. So whatever variable you got rid of at the very beginning is the last one that you solve for. I can plug these into any of my equations to solve for that. I'm going to use the 2a plus 2n equals 10. So 2 times 2, because I'm substituting in this for a, plus 2n equals 10. If I subtract that 4 over, I get 2n equals 6, and n equals 3. So my final answer here at this store, we have that apples are $2. I had a hard time writing that. Onions are $3, and blueberries are $4. So notice, just like any application problem, we started by writing our equation, and then we used our skills of solving a three-variable system.